In this video, we are going to discuss about more examples which are based on the partial derivative. So let us see first question. If u is equal log of x cube plus y cube plus z cube minus 3xyz, then prove that del by del x plus del by del y plus del by del z raised to power 2 u is equal minus 9 times x plus y plus z square. So first question says that how we can solve. So first, whatever we have the LHS, and that can be written as del by del x plus del by del y plus del by del z, and this can be represented two times. So I just say del by del x plus del by del y plus del by del z, and again del by del x plus del by del y plus del by del z of u. But whenever I apply u here, so what I'm just going to get del u by del x plus del u by del y plus del u by del z. And after that, what we have to do? We have to do derivative with respect to x, then we have to do derivative with respect to y, and then we will do derivative with respect to z, and that is going to be our final answer. So for our simplicity, I just call it v, where v is nothing but del u by del x plus del u by del y plus del u by del z. Then after, you can see first partial derivative with respect to x, and then we will do partial derivative with respect to y and z. So u is there. So what I'm just going to get del u by del x. So log of something. So 1 divided by something. And then derivative of the something with respect to x. So what we are going to get 3x square minus 3yz, because this is the constant, again this is the constant, so it will be the 0. But 3 times yz is a constant, so derivative of x is nothing but 1. So we get here 3 times yz. So similar argument you have to follow for the partial derivative with respect to y. So what you are going to get? 3y square minus 3xz and divide by the same. Same for the del u by del z. But v is equal del u by del x plus del u by del y plus del u by del z. But when I put all this value here, but we can observe that the denominator contains, that is x cube plus y cube plus z cube minus 3 times x y z. Our numerator contains 3 as a common factor, so we can take 3 times x square plus y square plus z square minus xy minus yz minus zx. But we know that the standard formula, that the x cube plus y cube plus z cube minus 3xyz is equal x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. But if we are supposed to put this formula here, so what I'm just going to get? So x plus y plus z into something. But in that case, you can observe that whenever you put here, so what you are going to get, this will be the cancel out, and you will get the 3 divided by x plus y plus z, that is way. But whenever you observe next, we want, our target is this one. So but we have simplest and represented as v. But v is nothing but this one. That means I have to do derivative with respect to x, then y, and then z. But already you are familiar that the y is equal 1 divided by x. So dy by dx is equal what? And that is, you know, that the minus 1 divided by x square. And the derivative of the x with respect to x is what? Exactly 1. And therefore we can say that our answer is what? Minus 1 divided by x square. And the same logic I'm just going to use here. So del by del x of this one, but just 3 is there. But 1 divided by x plus y plus z, so what we can say? Minus 1 divided by whatever we have, so x plus y plus z whole square. Then the derivative of with respect to x of the function, that is x plus y plus z, is what? Only 1. So we can say minus 3 divided by x plus y plus z raised to power 2. Same argument for the partial derivative with respect to y as well as partial derivative with respect to z. So we can observe that what we are going to get, minus 9 divided by x plus y plus z raised to power 2, and that is all about the solution. Let us see another question. If theta is equal to t raised to n e raised to minus r square divided by 4t, then find the n so that this is going to be happen. That means we have given that this function, also we are given that this one, but whenever both are the same, so what will be the value of n? That is we want to determine. So theta is equal to t raised to 1 into e raised to minus r square divided by 4t is there. So differentiating theta with respect to t, that is we want. So in that case, we will keep in mind that the remaining variable will be the constant. So this is the what exactly, this function contains t, also this function contains t. So that means product rule is there. Exponential is there. just I do derivative with respect to t of t raised to n. So n times t raised to n minus 1. Then plus t raised to n is there, then derivative of this exponential function. But we know that derivative of the exponential is itself, and then derivative of the minus r square divided by 4t with respect to t, and that is going to be what? Exactly r square divided by 4 times t square. And whenever we simplify, so what we are going to get? After taking e raised to minus r square divided by 4t common, we will get this one. So again, t square is there, so we can write as a numerator, so it will be t raised to n minus 2. But when we observe that LHS, theta is there, so we want first partial derivative with respect to r. So r contains here, so this is t raised to n as a constant quantity, so exponential is there. So what we are going to get? Minus 2r divided by 4t, but when you simplify and multiply by r square, so you are going to get minus 1 by 2, t raised to n minus 1, r raised to cube, e raised to minus r square divided by 4t. But again, I want the derivative of this one with respect to theta. So I have to use your product rule because this is contained also r. Again, this function contains r. So I have to apply the product rule, and t raised to n minus 1 divided by 2 with the minus sign, it is a common as a constant quantity. Say it is not going to be reflected with the derivative part. So I just take as outside the bracket, and I just do derivative for this part. So 3 times r square is there, and exponential as a constant, plus r raised to cube is there, and the derivative of this one, so e raised to minus r square divided by 4t, and the derivative of this one is going to be minus 2r divided by 4t. But whenever you simplify, so you will get the e raised to minus r square divided by 4t as a common. So remaining part will be minus 3 divided by 2 into t raised to n minus 1 plus r square, r into what, that is r square by 4, t raised to, this is what t is there, but t raised to n minus 1 is there, so I just multiply inside, so I will get the t raised to n minus 2. But given condition says both are the same, I just put right hand side, I'll put here left hand side. So whenever it is compared, so it is clear that this is going to be cancelled out, this is also going to be cancelled out, and also you can see that this is also going to be eliminated. So what we are going to get? N is equal minus 3 by 2. So that is we want, and that is the final answer. Now look at another question. If x raised to x, y raised to y, z raised to z is equal c. So we want to determine that x is equal y is equal z. Answer is like this one. So how we get? So for that, I have to assume that the logarithm throughout. So just take logarithm both the sides with the base is e, and applying the logarithm property. So we get here x log x plus y log y plus z log z is equal log c. Now the differentiating with respect to x. But what we have, x log x plus y log y plus z log z is equal log c. But we will always keep in mind that the z is a function of x and y. So whenever we do partial derivative with respect to x, so in that case we have to consider del z by del x. Okay, so here first product rule is that x is that derivative of the log x, that is 1 by x, because we are doing partial derivative with respect to x. Plus log x is that, so derivative of x, that is 1. So first one is over. This is a constant quantity, so it will be 0. This is not exactly constant because z function itself is dependent on x and y. But still we are trying to find out partial derivative with respect to x. That means I need to consider a product rule. So del z by del x is that whenever we have assumed that the log z is a constant, plus z is that, and derivative of the log z, that is 1 divided by z into del z by del x is equal 0. But from this it is clear that we can take del z by del x as a subject, and that subject will be minus times 1 plus log x divided by 1 plus log z. Now on this is already we have determined. Now again I have to do partial derivative with respect to y of this function. So whenever we do partial derivative with respect to y, so 1 plus log x is going to be constant quantity, and 1 divided by something whatever it is, because z is a function depend on x and y, and therefore what we are going to consider 1 plus log z is what exactly dependent. So in that case minus 1 plus log x is there. So minus 1 divided by 1 plus log z raised to power 2, and then we do derivative del by del z of 1 plus log z. So what we are going to get? 1 plus derivative of the 1 is, that is 0. Derivative of the log z, that is 1 divided by z. But z is depend on x, and that is we want, z is depend on y. So what we are going to assume that is the del z by del y. And so finally what we can say that del square z by del y del x is same as 1 plus log x minus 1 is plus divided by z into 1 plus log z raised to power 2 and del z by del y. But we are assuming that at x is equal y is equal z. What we can say about that? That is the same. So what we can say, 1 plus log x divided by 1 plus log z. Instead of that, you keep in mind that also just keep it as it is, and whenever you simplify you will get this one. But our target was to determine at x is equal y is equal z. So what we can conclude that minus 1 plus log x raised to power 2 divided by x into 1 plus log x raised to power 3. So 2 times will they get cancelled out, and we will get this one. This can be written as a power as a negative minus 1, but 1 is nothing but log e, and but again we can apply logarithm property. So x times log e x raised to power minus 1. But when you observe that, and this is what exactly our final answer.